Priscilla ma'am. Priscilla ma'am. Priscilla ma'am, can you hear me ma'am? Ma'am, your voice not audible ma'am. Good morning, sir. Good morning, sir. Good morning, sir.
Good morning.
Sir? Yes, sir.
Good
Yes, sir.
morning,
Now
ma'am.
I can hear your voice, so that's okay. A very good morning to one and all present here. It's my privilege to welcome our Honorable Vice Chancellor, sir, and respected Registrar, sir, the Controller of Examination, and all our HOD in Tamilnadu Education University, and assistant professors in TNTU. A special morning to our resource person, today's heroine, that is a Deputy Controller, Dr.C.E.Jeyanthi, Department of Educational Planning and Administration in our Tamilnadu Teacher Education University, Chennai. Ma'am, really very proud of you, ma'am, to meet you again in our Center for Civil Service and TNTET Coaching Center. On behalf of the Center and Tamilnadu Education University, I welcome you once again, ma'am. We are expected your valuable and knowledgeable guidance in our Mathematics and TET Part 2. Welcome, ma'am.
Thank you, ma'am.
And I welcome our most respected program coordinator, Dr. Prof.N.Ramakrishnan, sir. Members indicate Professor and Head, Department of Education Technology in Tamilnadu Teacher Education University, Chennai. Sir,
Yes.
I welcome you, sir.
Yes, welcome. Good morning. Good morning.
Thank you, sir. And my heartfelt gratitude to our Secretary, Mangalkrishna College of Education, and our ever supported Managing Director, Mr. Sakti Pranay, sir, and on behalf of the team, I welcome you once again. Participants, you are the core and pillar of all the webinars. I welcome you once again in everyone in our national level webinar on Mathematics in TET Part 2. Once again, I welcome you all. A special welcome to our director and the resource person. Thank you. Jayanthi, ma'am?
Yes,
Yeah, yes, ma'am. Yes, ma'am. You can proceed now, ma'am.
Thank you, ma'am. Thank you, sir.
Jayanthi ma'am, can you hear me ma'am?
Yes, ma, here. I am just sharing the screen. Please wait for some time.
Yeah, okay ma'am. Ma'am, your voice is very low ma'am.
Yes, ma.
Ma'am, don't close it ma'am. Wait for the program. Ma'am, don't close the program. Jayanthi ma'am. Jayanthi ma'am, can you hear me?
Yes, ma. Please,
Ah.
ma. Hello.
Yes ma'am, yes ma'am. Yes ma'am, again I give you the
It is
presenter
muted.
option ma'am. No ma'am,
it has
again
been
I give you the
muted.
presenter option.
Okay. தம்பி மியூட் பண்ணிட்டாங்க, அன்மியூட் பண்ணிட்டாங்கப்பா. ஓகே. சரிப்பா. ஓகேப்பா.
Jayanthi ma'am?
Yes, ma.
Yeah, can you receive the presenter option ma'am?
Yes, ma, I received.
Yes ma'am, yes ma'am.
Is the screen audible? Ma, is the screen visible to you? Hello?
No ma'am, no ma'am. Your screen is not.
Screen is not visible to you?
Yes ma'am, yes ma'am. Your screen is not visible to me.
One minute, ma.
Okay ma'am, your screen is visible ma'am.
But it is not coming for me, ma. Please wait.
Yeah, yes ma'am. Yes ma'am.
Hello?
Yes, ma'am. Yes, ma'am.
Ma'am, is the screen now visible to you?
Yes, ma'am. Yes, ma'am. It's visible, ma'am.
Okay. Okay, ma'am. Thank you, ma'am. Shall I start?
Yes, ma'am. You can start now.
Okay. Thank you, ma'am. Good morning, my dear participants. And first of all, I thank Dr. N. Ramakrishnan sir, a member syndicate, professor and head, Department of Education Technology, Tamilnadu Teachers Education University, for giving me this wonderful opportunity. Sir is doing service. Along this service, he is inculcating me. It is like a gift to me. Thank you, sir. Thank you for this opportunity given by you, sir. And I hope that I will do my best in this today's session. And without any further delay, we will move to the session. Okay. Already in the last session, we have seen an outline of all the mathematics in TET examination. And in today's class, today's session, we will discuss about an introduction to number system. That is, we have a doubt, what we have to study. A question arises within us. That is, we have to study from class 6 to 8 mathematics textbook. Apart from that, it is advisable to study up to standard 10. Why? Because to have a better understanding and in-depth concept knowledge, we have to go through up to 10th standard. This is my advice, my own opinion. And what are all the topics covered in the TET examination, in the syllabus they have given? I have given in the reference about this syllabus regarding to TET examination with respect to mathematics. In that, 6 topics have been covered, that is number system, measurements, algebra, life mathematics, geometry, and data handling. And today we will discuss about this number system. Let us move. What is number system? It is a complex one. In this complex number, it has both the real number and the imaginary number. With respect to real number, it consists of the rational numbers and irrational numbers. In this rational number, we have these integers, whole numbers, and natural numbers. Let us see one by one. What is complex number? Complex number, already we have seen that it is a combination of the real part and the imaginary part. Here A is the real part and B is the imaginary part. This I indicates the imaginary. And then rational numbers. Rational number is indicated by the letter capital Q. That is, Q is equal to P by Q. That is small p by Q. Here P and Q are the integers. That is, it belongs to I, capital I, that is integers, and Q not equal to 0. If you see this picture, you will have an idea that is the rational number is in the form of fraction. That is in the form of numerator and the denominator. Both the numerator and the denominator are in the form of integers. But the denominator, that is Q value, is not equal to 0 and it is denoted by letter Q. This is what about the rational numbers. And what is irrational numbers? The numbers which are not rational are said to be the irrational numbers. You might come across this pi value, e value, root 2, like that you might have come across. These numbers are all said to be the irrational numbers. And then we will move to that integers. Integers is represented by capital Z. That is, Z is equal to minus infinity to plus infinity. In this picture, you will see that minus infinity to plus infinity. That is, it consists of negative integers, 0, and positive integers. Negative integers up to minus infinity and positive integers up to infinity. And 0 lies in between. That is, 0 is neither positive nor negative integers. And next, natural numbers and whole numbers. The difference between this natural number and the whole number is that a simple difference is that natural number starts from 1 and the whole number starts from 0. That is, if a natural number includes 0, it will become the whole number. That's all. Thus we have seen about the number system, what is meant by complex numbers, and rational numbers, which is in the form of P by Q, and the irrational numbers, which where the rational numbers, apart from the rational numbers, all the other numbers are said to be the irrational numbers. For example, pi value, e value, like that, and the integers minus infinity to plus infinity, and the natural numbers and the whole numbers, and the difference between natural number and whole number, and the relationship between the natural numbers and whole numbers. And then we will go to the problems. Rational numbers. See here, find any two rational numbers between 1 by 2 and 2 by 3. In the sum itself, 1 by 2, already we have seen in the interaction that 1 by 2, that is in the form of fraction, it is a rational numbers, and 2 by 3. If, for example, I will give an example, that is, what is the number that exists between 2 and 4? What is the number that exists between 2 and 4? Automatically, immediately you will say that it is 3. Why? Because we have that number system 1, 2, 3, 4, 5, 6. But specifically why I am asking here means the number between 2 and 4 is 3. How means we have to add the average, that is 2 plus 4 divided by 2. 2 plus 4 is 6. 6 divided by 2, that is 6 by 2 is equal to 3. That is the average of two numbers will give the middle value. Likewise, we have to use that technique here in this sum. Find any two rational numbers. That is, in between this 1 by 2 and 2 by 3, there is a rational number. We have to find that. So, in between this, we have to find. So, I am taking the average of this 1 by 2 and 2 by 3. How to take average? That is, we have to add these two numbers and divide it by 2. Divided by 2, we have taken it as 1 by 2. Addition of this 1 by 2 and 2 by 3, and then this 1 by 2 remains same, and we have to take LCM 6 and cross multiply. You will get 3 plus 4 by 6, and this 1 by 2 remains as it is. 3 plus 4 is equal to 7. 7 divided by 6, which is equal to 7 by 12. So we have find a rational number, one rational number, that is in between this 1 by 2 and 2 by 3, we have find a rational number 7 by 2. But in the question, they have asked two rational numbers. Here, see here, we have find 1 by 2, in between 1 by 2 and 2 by 3, this 7 by 2 we have found, but still we have to find another rational number. So I am trying this in between this 1 by 2 and 7 by 12. Again see here, 1 by 2 and 7 by 12. Again the same procedure as it is. That is the average of 1 by 2, this 1 by 2 and 7 by 12, which is equal to 1 by 2. Taking LCM, 6 plus 7, this 1 by 2 remains as it is. 6 plus 7, 13 by 12, which is equal to 13 by 24. The other number is 13 by 24. So like this, we have to find the number between these two rational numbers. We can try this also. We can find a rational number between 7 by 12 and 2 by 3 also. Okay, I think you have understood this. We will move to the next problem. Highest common factor. That is simply we will represent as HCF. Find the HCF of the numbers 40 and 56. In this sum, I am going to give two different models. That is, first model, we have to find the factors of this 40 and 56. Separately, we have to find, that is, the prime factorization of 40 is 2, 2, 2, 5 and 1. You write like this. And the prime factorization of 56, the same 2, 2, 2 into 7. The highest common factor is nothing but we have to take the numbers which are common to both the factors 40 and 56. That is 2, 2 and this 2. That is 2 into 2 into 2, that is equal to 8. This is one of the models. That is the HCF of the number 40 and 56 is 8. You can try this model also. I have given here. It is very simple. First we have to take this 40 and 56. Take the biggest number first, that is 56. This 56, and how many times the smallest number, that is that 40, comes in this 56? Only once. So I put 40 one time, and what is the remaining value? 16. 40 plus 16, 56, that is 40 comes only once. And then the next step is, again you put this RHS, that is 40, in this 40 plus 16, which is the biggest number? Yes, 40 is the biggest number. So I took 40 again, and how many times this 16, smallest number, comes? 2 times. That is 16 into 2 is equal to 32. That is 32. What is the remainder of this 40? 8. So I put 8. 16 into 32 plus 8. And again in this RHS, which is the biggest one? 16. Yes, 16 I have put here. And how many times this 8 will come? Twice. That is 8 into 2, 16. And the remainder is 0. We have to try till that smallest number becomes 0. And this 8 value is said to be, this 8 is said to be the HCF of the number 40 and 56. I have given 2 models. Which one is easy for you? You take it as a model. And next we will move to the other sums. Find the smallest number that can be divided by 254 and 508, which leaves the remainder 4. Find the smallest number that can be divided by 254 and 508. That can be divided with, it is a number that can be divided by 254 and 508. We don't know that number, but a special hint is there. It leaves the remainder 4. This is the hint they have given. Just you take the LCM of this 254 and 508. The LCM of this 258 and 508 is 508. Here we have took the LCM, and the LCM of these two numbers is 508. We have found the LCM. And one more thing, the next half question is, it leaves the remainder 4. It leaves remainder 4 means if we add that 4 means automatically that number will come. Therefore, as we need the remainder 4 while dividing, the required number is 4 more than the LCM. So we have to add that 4 with this 508, and ultimately we will receive 512. This is the smallest number that can be divided by both 254 and 508. Very simple. See this sum. Just we have to find LCM and add this remainder. That's all. This is the smallest number. For example, what will be the number if it leaves remainder 6 in the same problem? What will the number? What will be the number if it leaves the remainder 6? Yes, in this 508 we have to add 6, which is nothing but 514. Yes, I think you have understood well. That is, we have to find the smallest number by taking the LCM and adding the remainder. That's so simple. And next we will go to the next sum. The LCM of two numbers is 432 and the HCF is 36. If one of the numbers is 108, then find the other number. There is a formula for this, which is the product of two numbers is equal to LCM and HCF. That is, the product of LCM and HCF is equal to the product of any two numbers. Here, two numbers, the LCM of two numbers they have given 432. See here, the LCM of two numbers is 432 and the HCF is 36. If one of the number is 108, in the formula they have given that product of two numbers, but in the problem they have given only one number. We have to find the other number. Therefore, the other number, what we don't know, we get as it is, like a variable x, like that you can put. That is 108 into x. You see here, 108 into x. Why? Because we don't know the other number. Product of two numbers, which is equal to this HCF, this LCM value we have substituted as 432 and the HCF value we have substituted as 36. Therefore, the other number is equal to this 108 is in a multiplication. When it comes this side RHS, it becomes as division. When these numbers get cancelled, we will get 144. This is the other number. I want to check whether my answer is right or not. Just you substitute the obtained number in the formula. That is product of two numbers. Already 108 is there. The other number I have found 144, which is equal to LCM 432 and HCF 36. If I multiply this, 15,552, 15,552. Therefore, our answer is right. This is a simple method to check our answer. We will move to the next one. Simplification. In the name itself, simple, simplification. We have to make this complex into simple is simplification. So we simplify root of 98 by 162. It is like a square form, the number is big number, like that we feel no. We have to simplify this, that's all. We have the formula root of a by b is equal to root a by root b. Anyway, we are not going to use this formula. Directly we are going to the sum to simplify. While you are doing the simplification problem, the only thing you have to keep in mind is we have to find the common multiples of both the numerator and denominator. If you find the common multiples of both the numerator and denominator, it is easy to simplify so that it gets cancelled. So root of 98 by 162 is equal to 2 into 49, 98. 2 into 81, 162. That is 2 is common multiple of both this 98 and 162. Therefore, this 2 gets cancelled. And then the remaining thing is root of 49 by 81. Further, we have to simplify. See, by seeing itself, we have an idea that 49 is nothing but the 7 square and 81 is nothing but the 9 square. And again, here we come, always the square and root gets cancelled in any place. So this square and the square root get cancelled and we get 7. And in the denominator also the same. This square root and this square get cancelled and we get remaining 9. That is, this root of 98 by 162 has been simplified as 7 by 9. This is the simplified form of this number. For example, I have given here 9 by 12. 9 by 12 is equal to 3 by 4. That is, 9 by 12 is a big number to the children. And 3 by 4 is a simple form, simplified form of that 9 by 12 is 3 by 4. That's all. That is the only thing we have to keep it in mind is whenever you are doing a simplification problem, we have to find the common multiples of the numbers both in numerator and denominator. That's all. And the next term, simplify the following. Root 63 minus root of 175 plus root 28. Yes, we will see. Already I have told that 63, 175, 28. You generalize an idea that there will be a common multiple when they are giving this kind of sum, simplifying sum. There will be a common multiple. We have to find the common multiples. So 9 into 7, I think that 7 will be the multiple of these three numbers, that is 9 into 7, 25 into 7, 175, 4 into 7, 28. So I have changed this 63, 175, 28 into split into 9 into 7, 25 into 7 and 4 into 7. And then see here, this root 9 has become 3. How? The root 7 remains as it is, and here also this 25 becomes 5 and the root 7 remains same, and here this root 4 becomes 2 and this root 7 remains same. How means this root 3 we can write it as 3 root of 3 square. When we are writing root of 3 square, the square and the 2 gets cancelled, square root gets cancelled and we get 3. Likewise here also 25 we can write it as 5 square, that square and square root get cancelled and we get 5, and here we can write it as 2 square root of 2 square. Hello? Hello?
Yes, ma'am. Ma'am, you can proceed, ma'am.
Okay, ma'am. Thank you, ma'am. And the root of 4, this root 4 becomes 2 square, root of 2 square. That root and square get cancelled and we will get this 2. That's all. Now we have find the common multiples. That is, we are simplifying step by step. And see here, we add this positive items in one side and negative terms in one side. That is, what is the positive terms here? 3 root 7 and 2 root 7 are the positive numbers. So I assembled here, and this minus 5 root 7 stays here. This addition of this 3 root 7 and 2 root 7 is nothing but 5 root 7. This 5 root 7 minus 5 root 7, it becomes 0. That is the simplified form of this root 63 minus root of 175 plus root 28 is nothing but it is 0. Yes, I think you might understand, and I will move to the next problem. Yes, this is a word problem, very interesting word problem. I know that, I think that you all know the area of the square and the perimeter of the square. If not, I will give the formula for that. The area of the square is A square. A is nothing but the side of the square field. And then the perimeter is 4A. 4A means, that is, see here in the picture. In the figure, see here, this side is A. And what is the area means? A into A. See here, the question mark remains that A into A square. This is the area of the square field. And what is the perimeter means? Starting from here, we have to move here, and then there, this side, and again this side. That is 4A. To cover the perimeter, a person needs to travel 4 sides. That is 4A. So the perimeter of the square is 4A. This is the formula for that. Given that here the problem is that they have given that the area of the square field. The area of the square field is 3136 meter square. From this area, I have to find A. Why? Because means I need that A to substitute in the perimeter formula 4A. The area of the square, the perimeter of the square is 4A. For that purpose, I need A. But here they have given A square. A square is 3136. What about A? A is equal to root 3136. That's all. That is, A square is equal to 3136. What about A? A is nothing but the root of 3136. That is, if we take the root of 3136, we will obtain this 56. It is nothing but 56 into 56, 3136. That's all. And here I have found, see here, we have found 56 meter. That is, the value of A here is 56 meter. From this A value in the problem, if they have given to find the value of A, it is enough. That is 56 is enough. But in this problem, they have asked perimeter. So the perimeter of the square field formula is 4A, which is equal to 4 into that obtained 56 value, which is equal to 224 meter. This is a simple way to find the perimeter of the square. Next, we will move to the next one. I have a small explanation about the cubes, like the powers. 2 cube. What is 2 cube? We all know that 2 into 2 into 2, 2 cube, which is equal to 8. And what is 4 square? Yes, 4 into 4, which is equal to 16. If it is like this means, easily we can say that is 2 cube is 8 and 4 square is 16. But the condition is like this. Find the value of 81 power 5 by 4. It is in the form of fraction. It is little bit difficult when comparing this. So, what is the way to find the value of this kind of powers? We will see. 81 power 5 by 4. I will give a technique you follow in all the problems. That is 81, write as it is. this denominator value, see here, this 5 by 4 in this fraction 5 by 4, what is the denominator value? Yes, 4. That 4 you have to write here, that is 4th root. And 81, this 5 remains same. See, the numerator remains here itself and the denominator goes here. This is same for all the problems. And the next step is, see here, this 81, we can write it as 3 into 3 into 3 into 3. That is 3 3s are 9, 9 3s are 27 and 27 3s are 81. So 87 can be simplified as 3 power 4. Why we have did like this means to get cancelled this fourth this root and this 4 and this 4 need to get cancelled, so that only we have changed this 81 as 3 power 4. Now easily this 4 and this 4 get cancelled and the remaining is 3 power 5, which is nothing but 3 into 3 into 3 into 3 is equal to 243. This is the simple form to find the value when the power is in the form of fraction. And see the next problem. That fraction, that too it is in negative form. In this case, what we have to do means, we have one formula that A inverse is equal to 1 by A. A inverse is equal to 1 by A. See here, this is like A. And this is that inverse form, that is A inverse. A inverse, we can write it as 1 by A, no? Therefore, 1 by 64 power 2 by 3. Here this minus will not come, the negative will not come. Why? Because A inverse is equal to 1 by A. And again, that technique what I have told, no? That we are going to adapt here. That is same. This denominator goes here and it becomes cube root. And this 2 remains as square as it is. This 64. Again, this 64 we can simplify as 4 cube, no? 4 into 4 into 4. 4 4s are 16. 16 4s are 64. So here, what we will get means 4 cube. 4 cube. At that time, that cube and this 3 and this 3 will get cancelled and we will get only 4, that is that 4 and this 2 becomes 4 square. Like this here we saw, no? This 4 and 4 get cancelled and 3 power 5. Like that, this 4 cube, the 64 is nothing but 4 cube. That cube and this cube root will get cancelled and the remaining 4 we will get. This square remains as it is. That is 1 by 4 square, which is equal to 1 by 16. Therefore, the value of this 64 power minus 2 by 3, which is nothing but 1 by 16. The simple thing is, we have to know the technique of writing this fraction. Yes, we will move to the next sum. Express the following in the form of 2 power n. We know that 8 can be expressed as 2 cube, that is 2 into 2 into 2. 32, we can write it as 2 into 2 into, that is 2 power 5, 32. And root 2, we all know it is 2 power 1 by 2. This, up to this, we are all right. But when coming to the fifth sum, root 8, that is root 8, this root 8 can be divided into 3 multiples, that is 2 into 2 into 2. Root 2, root 2, root 2, it becomes root 8. So I split that root 8 into 3 root 2s. And we know the format of root 2, that is root 2 is 2 power 1 by 2. In this place, we are writing 2 power 1 by 2. How many root 2s are there? 3 root 2s are there. So I put the power as 3. Whenever it is in the form of 2 power, any fraction, whole power, cube or square, we have to multiple this square and this cube. It is 2 power 1 by 2. When it is in the form of like this means, we can add the multiple this 3 in this 1 by 2. Therefore, it becomes 2 power 1 by 2 into 3, which is equal to 2 power 3 by 2. This is the final answer of that. So, the root 8 can be split into root 2, root 2, root 2 and then 2 power 1 by 2. Already we have 3 roots. So, we put 3 power and this 1 by 2 got multiple with 3 and ultimately we get 2 power 3 by 2. And then we will move to the next sum. Arrange in ascending order. See here, 24, 12, 54, 3. We can arrange this number in ascending order, that is 3, 12, 24 and 54. We can arrange it easily. But see here, cube root of 2, square root of 4. It is a little bit difficult when comparing with this sum. That is by ascending, this one is easy, the above one is easy. But when coming to this type of question, it is a little bit difficult. What we have to do is very simple. We have to make this cube root and square root and this 4 into a common root. That is the common number. The denominator should be common. For that, first we have to take the LCM of this 3, 2 and 4. We have to take the LCM. The LCM of 3, 2, 4 is 12. And first, one by one we will take. First we take the first number, that is cube root of 2. Cube root of 2, we can write it as 2 power 1 by 3. But what is our position is, we have to make it as same for all the 3 numbers given here, no? All the 3 numbers, we have to make a common multiple. Therefore, I have to make it as 12. This 3, I need to modify it as 12. So I am going to multiply and divide by 4, so that only it will not, the value does not change, but it is similar to 2 power 1 by 3. That is 4 by 4. 4 by 4 means 4 by 3. Oh, sorry, 4 by 4, it is equal to 4 by 12. 2 power 4 by 12. That is, whenever it is in the form of fractions, we just write it as 12 root of 2 power 4, as I said earlier. And 12, 2 into 2 into 2 into 2, that is 2 power 4, which is equal to 16. Just we have found for only one number. For this number, we have find an equivalent number, that is root of this 12 root of 16. And then for next number, we have to find square root of 4. Again, we are going to do the same method as we done earlier. That is 4 power 1 by 2. Again, here the denominator is 2. This 2 we have to change it as 12. For that, what we have to do? 12 is 2 into 6, 12. So we are going to multiply in the numerator as well as in the denominator with 6. So we will get 4 power 6 by 12. Again, we can write this fraction form of powers into 12. This denominator comes here and the numerator remains as it is. So here 12 root of the 16, 12 root of 4096. And again the same method is followed for the third number also. And finally, we have found root of 1216 is 27 and 4096. We have arranged by seeing this number which is inside the square root. Why? Because means we have made this 12 into common, but in the sum 3, 2, 4 we cannot arrange here. But once we have taken LCM and modified like this, easily we can arrange in this order. That's all. And next we will move. See, one example I have given here. Cube root of 2 power 3. What is the value of that? It is nothing but 2. As we have seen earlier, this cube root and 3 gets cancelled and we will have only this 2. The same technique is we are going to adapt here. Multiply the cube root of 40 and the cube root of 16. This 40 can be factorized into 2 into 2 into 2 into 5. That is 2 2s are 4, 4 2s are 8 and 8 5s are 40. That this 40 is factorized into this form. And the same for 16 also we are going to write like that. 2 into 2 into 2, that is 2 power 4, which is equal to 16. That is 2 into 2 into 2. See here, this 1, 2, 3, this 2, 2, 2, we can write it as 2 cube. Yes, we can write 2 cube. That 2 cube and this 3. See here, I have given an example, no? 2 cube, and this 3 get cancelled and it becomes 2. The same technique is adopted. 2 cube, cube root of 2 cube, that cube and that 3 get cancelled and we get only 2. And this 5 remains same, cube root of 5. The same is adopted here. Since here the cube root is available, we cannot take this as 2 power 4. Why? Because since we are going to get cancelled, we are going to make it as cancelled. So first we are taking this 2, 2, 2, only this 2, 2, 2. Why? Because this 2 cube will comes and that cube and this cube root will get cancelled and only 1, 2 will remain and this cube root will remain as it is. So 2 into 2, 4, this cube root of 5 and this cube root of 2, multiples got multiples and the cube root is common here. So cube root of 2 into 5 which is equal to 10. Therefore, the multiple value is cube root of 10. I hope you have understand this problem, and next we will move to the next. The mass of the earth is 5.97 into 10 to the power 24 kilogram and that of the moon is 0.073 into 10 to the power 24 kg. What is the total mass? One thing we have to keep it in mind that whenever this power is same, we can keep as it is, as common. The only thing what we are going to do is they are asking the total. We are going to find the total mass. Just we have to add this 5.97 and 0.073. The one thing we have to concentrate is the decimal point. That is 5.97 in plus 0.073 into 10 to the power 24. The 10 to the power 24 is common for both the numbers. So we keep it as take it as common and the remaining 5.97 plus 0.073 and just you are adding. While adding in this place, we will do a small mistake when sometimes to overcome this you have to write like this 5.97. This decimal you have to write as it is and then you have to write number to avoid the small mistakes and we will get 6.07 I am so sorry 6.043 into 10 to the power 24. And next, this is a simple thing, but sometimes we will make mistakes while adding the decimal number, so that only I took. The next, A and B are two positive integers such that A power B into B power A is equal to 800. I don't know what is that A and what is that B, but that A power B into B power A is the product of that two is 800. My job is to find the value of that A and B. That we can factorize this 800 into 2, 2, 2. That is 2 into 2, 4, 2s are 8, 8 2s are 16, 16 2s are 32. Like this, if we factorize this 800 means you will get like this. How many 2s are there? 2 into 2 into 2, 3, 4, 5. That is 5 2s are there. That is 2 power 5. See here? 2 power 5. And how many 2s are there? 2. That is 5 square. 5 square. See here. This is in the form of this. This 800 is in the form of 2 power 5 into 5 square. But this 2 power 5 into 5 square is in the form of A power B into B power A. So, from seeing from these two, we come to a conclusion that the value of A is 2 and the value of B is 5. That's all. Like this, for greater number, they will ask. Yes, we will go to the next. Arithmetic progression and geometric progression. There is a formula for finding arithmetic progression, a general formula for the general term. That is Tn is equal to, see here, Tn is equal to, see here, Tn is equal to A plus n minus 1 into D. This one is. This is the general term of arithmetic progression. Here, what is this n, what is this a, and what is this d? Just I will explain. This n is nothing but the nth term. Here they are in the question they are of the 15th term, 24th term. That is the nth term. That is we have to find the 15th term, T15. And a is the first term. What is the first term in this 3, 5, 15, 27, 39. What is the first term here in this arithmetic progression? Yes, 3 is the first term. And what is this D? What is this D means? The difference between the two numbers. Any two numbers. The difference between the next two numbers. That is, the difference between 15 and 3 is 12. And the difference between the 27 and 15 is 12. And again, the difference between 27 and 13. We should not say it as minus 12. We are asking the difference. We are not subtracting. We are saying that this difference. So we have to say it as 12. 39 minus 27, 12. So in this arithmetic progression, the difference among the next number to the preceding or succeeding number is 12. In the sum, they have asked, find the 15th term. We have the formula that Tn is equal to a plus n minus 1 into d. T15 is equal to, we are substituting the values of n, a and d. The value of n here is 12. See here? I'm so sorry, the value of n is 15. Why? Because means they are asking the 15th term. So we have took 15. And a plus the value of a, we will substitute later. And here n is 15 minus 1 into d. Again a plus 14d. We know the value of a and the value of d. What is the value of a here? A is nothing but the first term. The first term is here 3. So I substitute 3 plus 14 into d. D is the difference between the two numbers, that is 12. When you simplify, you will get 171. This is the 15th term in this arithmetic progression. The first term is 3, second term is 15, third term is 27, fourth term is 39, and they are asking 15th term. It is a little bit difficult, no? 39 and again 12 or 41, like that we have to add 12, 12, 12. Instead of that, we are having this formula. We are using this formula and finding the 15th term or 24th term or 100th term or 200th term, any term values we can find by using this formula. And then you try this one, T24, that is the 24th term. The T24 term is instead of that 15, we just put 24, that's all. A is as it is 3 and D is as it is that 12, that difference. And a plus 23d, a is 3 and 23 into 12, which is equal to 279. And sometimes they will ask the nth term. And then nth term, what is that nth term means? Nth term when this a value is 3 and the difference is 12 means Tn is equal to a plus n minus 1 into d. Here they are asking the nth term. Therefore, we are substituting the value of a and the n term is n itself and d is 12 and Tn is equal to, just we are multiplying 3 plus 12n minus 12. After simplification, you will get Tn is equal to 12n minus 9. Likewise, they will give the arithmetic progression. From that arithmetic progression, we have to find the 15th or 24th or nth term, any term they are asking, we can find easily. And next we will move. Find the number of terms in the AP. AP means the arithmetic progression. 3, 6, 9, 12, 1, 1, 1, 111, like that. In the previous term, what we have found means the 15th term. They are asking in the arithmetic progression, what is the 15th term? What is the 24th term? What is the 50th term? What is the 70th term? Like that. In an arithmetic progression, they are asking the number. What is the term? What is the 15th term, like that? But in this number, what they are asking means find the number of terms in the AP. Find the number of terms in the arithmetic progression. They have given the n number. Nth number means 111 they have given. But I have to find how many numbers are there. For that, I will give a small example. From that you can understand what I am saying. If the last term is 9, that is, if they have given 3, 6, 9. How many terms are there? 3 terms are there. That is, from 3, 6, 9 up to 9, we have 3 terms. Likewise, the formula here is n is equal to L minus a by d plus 1. This is the formula to find a number of terms in the arithmetic progression. You just substitute here L minus a by d plus 1. L is the last term. and A is the first term and D is the difference. You just substitute 9 minus 3 which is equal to 6, 6 by 3 plus 1 which is equal to 2 plus 1. This is 3 and 6 get cancelled, and 2 we will get 2 plus 1, 3 terms. Simple. That is 3, 6, 9. Totally there are 3 terms. This is just a cross check with a small example, and now we will go to this big sum. Find the number of terms in the arithmetic progression from 3 to 111. Here, what is the A value? Yes, 3 is the A value because it is the first number. And what is L? L is 111. L represents the last number. And what is the difference D? Difference D is nothing but the difference between 6 and 3, the difference between 6 and 9, the difference between 9 and 12, which is nothing but D is equal to 3. Simply we are substituting in this formula L minus A by D plus 1. After simplifying we get 37. Therefore, in this arithmetic progression from 3 to 111, totally we have 37 terms. That's all. This is the formula for finding the number of terms in the arithmetic progression. Hope you might understand. And next we'll go find the sum of first 15 terms of the AP. In the first sum, they ask us to find the 15th term, and then in the second, they ask the sum of the terms in between that 3 and 111, and here they are asking the addition of 8 to 5, 3 by 4. Just we have to add. For this also we are having a formula, that is the sum of first n terms of AP is equal to n by 2 2a plus n minus 1 into D. This formula you have to memorize. The first term here, what is the first term here? Yes, 8. And what is the n value here? Yes, the 15th term, that is n value is 15. And what is the difference between this? We have to find the difference between A and 7 1 by 4. This is a mixed fraction. By 7 4 are 28, 28 plus 1 29 by 4 minus 8. We will get minus 3 by 4. That is, the difference is minus 3 by 4 in this arithmetic progression. Therefore, we have got all the values so that we have to substitute here. That is, n value we have, that is 15, and A value we have, that is first term 8. And this D value we have find that 3 by minus 3 by 4. Just we have substituting and finding the values of we are finding the values of this 165 divided by 4. And then we will move to the next problem. In an arithmetic progression, the sum of first n terms is problem they will ask like this. For understanding, I have taught the previous sum, but the sum in the examination they will ask little bit critical. That is, in an arithmetic progression, the sum of first n term is 5n square by 2 plus 3n by 2. They have given in this format. Find with the help of this nth term, we have to find the 17th term. Yes. What is an idea of that is, they are asking the 17th term. Specifically, they are asking the 17th term. For that, we have a better idea that how to find the 17th term is, see here, 17th term is equal to the sum of 17 terms minus the sum of 16 terms. That is, when we separate the sum of 17 terms, when we are separating the sum of 16 terms in the sum of 17 terms, automatically we will get the 70th term. See here, the 17th term can be obtained by subtracting the sum of 16 terms from the sum of first 17 terms. That is, this is the nth term. We have to find the 17th term and the 16th term. See here, just we are substituting the values of 17 and 16 here. 5 into this instead of this n we have put 17. Here also the same thing we have done. And after multiplication, just we simplify and we got 748. This is the sum of 17 terms. And what about this sum of 16 terms? It is nothing but instead of 17, we have substituted 16, that's all. 5 into 16 square plus we are just substituting the value of 17 and 16 in this general term, that is the nth term. That is for 17 we have got 748 and for 16 we have got 664. And the logic here is when we will get the 70th term means if I subtract the sum of 16 terms from the total number of 17 terms, I will get the 70th term. That is sum of 17 minus sum of 16. That is 748 minus 664, which is equal to 84. Therefore, the 70th term is 84. This is the logic behind this. Yes, we will move to the next. I think we are going to geometric progression. Two types of progression we are already we have seen the arithmetic progression, and now we are seeing the geometric progression. For geometric progression, the general form of this geometric progression is here a, comma ar, comma ar square. We all know that what is a, and what about this r? The r is nothing but the ratio, or is the ratio, common ratio. Here, what is the problem given is, find the geometric progression whose first term and common ratios are given. What is first term? The first term is indicated by letter A and the common ratio by small r. And A is equal to -7 and r is equal to 16. Just we are going to substitute in the general form. The general form of geometric progression is A, ar, ar square. Likewise, it goes on. Just we simply substitute the values of -7 and 6. We will get this one. What is the first term? A. A is -7. And the next term, what is the next term? AR. A is -7 and R is 6. -7 into 6 is equal to -42. Likewise, we have to find. And then the same formula we can adapt for this sum also. Yes, the only thing we have to keep it in mind is geometric progression is nothing but a, comma, ar, comma, ar square, and so on, etc. That is the general form of the geometric progression. They will give the first term and common ratio. The first term is nothing but a, and the common ratio is r. By using this a and r, we can find the geometric progression. Next we will move. The sum of first n. This is, I have given three formula. The sum of first n natural number is 1. We know that in the introduction we have seen that natural number is nothing but it starts from 1. That is 1 plus 2 plus 3 up to n. The sum of first n natural number. So they have taken it as a n. The formula for that is n into n plus 1 by 2. And then another formula, the sum of squares of first n natural number. What is the difference between the previous one and this one is, here sum of first n natural numbers. So 1 plus 2 plus 3. Here the squares of first n natural numbers. So 1 square plus 2 square plus 3 square. This RHS is n into n plus 1. 2n plus 1 by 6 is the formula for that. 1 square plus 2 square plus 3 square. That is the sum of the squares of the first n natural number is n into n plus 1, 2n plus 1 by 6. You have to memorize this. And other formula, the sum of cubes of first n natural number, that is 1 cube plus 2 cube up to n cube is n into n plus 1 by 2, the whole square. In all these above three formula, we are going to do one sum. First we will see a small simple sum. Find the sum. Sum is total. 1 plus 3 plus 5 up to 40. It's very simple. That is the sum of first odd n natural numbers. Odd n natural numbers is n square, which I didn't say previously about that formula. Just now I am saying 1 plus 3 plus 5 up to 40 terms. How many terms are there? 40 terms are there. The sum of odd n natural number is n square. Here n is 40, therefore the value is 40 square. That is n square is 40 square, which is equal to 1600. For the second sum, see here, the sum of first n natural number. We have the formula for the first n natural number, that is n into n plus 1 by 2. But the question is like this: 2 plus 4 plus 6 up to 80 like that. The question is like that. What to do at that time? What we have to do is you take the common numbers. That is, it is see here, it is a multiple of 2. If you take the 2 as common, we will have this formula. There is 1 plus 2 plus 3, the sum of first n natural numbers. It is in the form of that formula. So we are going to take 2 as common. So I took 2 as common, and the remaining I am writing 1 plus 2 plus 3 up to 40. And now it is in the form of the sum of n natural numbers. See here, 1 plus 2 plus 3 up to 40. That is n plus n into n plus 1 by 2. This formula I am going to adopt there. Here, the value of n is 40. That's all. 2 into n plus 1 by 2. That is, this 2 remains as it is here, 2. And for this 1 to 40, it is the sum of first n natural numbers. That is, this n value is 40. I am substituting the value of n here. That is 40 here. And after getting cancelled, we will get 1640. This kind of problem they will ask in the examination. And then we will move to the next sum, next model. See here, 1 square plus 2 square up to 19 square. If they ask like this, it's very simple. We are having the formula for that. We have already seen 1 square plus 2 square plus 3 square plus 4 square up to n square. The formula is n into n plus 1, 2n plus 1 by 6. By directly we can substitute that formula here. That is, the value of n is 19. Just I am substituting the value of 19 n value, that is n into n plus 1, 2n plus 1 by 6. After simplifying this, we will get 2470. If it is a simple question paper, they will ask like this, 1 square plus 2 square. Directly they will give the n value, and you have to substitute that value of n in the formula, that is n into n plus 1, 2n plus 1 by 6. But if the question paper is little bit difficult, means the second sum like this it will come, 5 square plus 10 square plus 15 square plus 105 square. In this step, what we have to do, what you are identifying, what you are coming to know means there is a common multiple 5, 10, 15, 105. We can take this 5 as common. If we take 5 as common as the previous sum, 5 square will come, and the remaining 1 square, 2 square, 3 square, 4 square, 21 square as it is. And this 5 square becomes 25. See here, it is in the form of sum of squares of first n natural numbers. That is, sum of square, that the formula is n into n plus 1, 2n plus 1 by 6. It is in the form of like this. 1 square plus 2 square, no? We substitute here and find that value, no? Like that, we have to find the value of 1 square up to 21. There we have find for value of 19, and here we are going to find the value of this 21. And when the value is 21, 25 into n plus 1, 2n plus 1 by 6. After simplifying this, we will get 82775. Yes. If it is too hard, if the question paper is very tough, means at that time this kind of question will rise. That is 15 square plus 16 square plus 17 square plus 28 square. No need to bother about the terms. You maintain some techniques, that's all. What technique we are going to adopt? See this picture I have given here. I want the distance between B and C. I want the distance between this blue color, no? I want the distance between B and C. But in the sum, they have given from A to C. But I need only B to C. For that, I need to cut this AB. That's all. This is the simple logic behind this. If I need the values from B to C, distance from B to C, which they have given from A to C, I just want to cut this area. That is AB. If I cut means automatically I will receive this BC area. That is the logic here. See here. A is 1 and C is 28. But here A is not given, that is 1 is not given. Instead of that, they have given 15. That is the middle value they have given. That is here they have given this 15th value. But I need the value from 15, the sum from 15 square to 28 square. So I have to write like this. First I have to write the whole, this maroon color, no, this whole thing I am going to write, that is 1 square plus 2 square starting from 1. See, starting from 1 and finishing with 28. That is 1 square plus 2 square up to 28 square, because 28 square is given here. From that, if I subtract up to 14 terms, I will get the answer from 15. That's all. So 1 square plus 2 square plus 3 square up to 14 square I subtracted. So the value of this is n into n plus 1, 2n plus 1 by 6 for this 28. And the same formula I am substituting this for the 14. The value of n value is 14. N into n plus 1, 2n plus 1 by 6. After getting simplification, we will get 71714 minus 1015, which is equal to 6699. The simple logic here is, when the square terms is given, in between means we have to find from the starting to end and then reduce the thing what we didn't need. If we are not, if you don't want that, means we have to delete it. That delete only we are subtracting here. Yes, we will move to the next sum with respect to cube terms. That's all. Find the sum of 1 cube plus 2 cube plus 3 cube up to 16 cube. The formula for that I have given already. That is, see here. The sum of cubes of first n natural number is 1 cube plus 2 cube plus 3 cube up to n cube is n into n plus 1 by 2 the whole square. This formula we are going to apply there. See, it is in the form of 1 cube plus 2 cube plus 3 cube. Here the value of n is 16. Simply we are substituting the value of n here, that is n into n plus 1 by 2 the whole square, and simplifying, this 2 and 8 get cancels and we will get 136 square, which is nothing but 18496. That's all. And the same problem arises here like this. They are asking from, if it is from the starting one, it is very easy for us. If it is from the middle, a little bit critical, I told you, know, like that only here they have given. From 9 cube they have started. So the first sum is started from 1. It is very easy to apply the formula. But when in case of this 9 cube, we have to find from 1 to this 21. And if we reduce the number up to 8 cube, we will get 9 cube plus 10 cube plus 21. The technique is adapted here. See here, 1 cube plus 2 cube up to 21 cube minus 1 cube to 8 cube. So that we will get from 9 cube plus 9 cube to 21 cube. The same technique is adapted for 21 cube. They have n into n plus 1 by 2 whole square formula. We have subtracted minus n into n plus 1 by 2 the whole square. I am so sorry. Instead of minus, I have put equal to. This is minus. Minus 8 into 8 plus 1 by 2 the whole square. That is 231 square minus 36 square, which is equal to 52065. The simple thing is, we have to find fully, and then we have to reduce the thing whichever we don't want, and the remaining value is the 9 cube, 10 cube plus 25 cube. That's all. And so far we have seen yes. In number system, we have seen what is complex number, real number, imaginary number, and rational numbers, integers, and the difference between the whole numbers and natural numbers, and about the irrational numbers. The rational number that is in the form of p by q, and the irrational numbers is pi value, e value, root 2 value, and about the integers minus infinity to plus infinity. The relationship between the natural number and whole numbers, and the difference between the natural numbers and the whole number. And we have seen summary about finding a number, rational numbers between two rational numbers, and the HCF, that is the common highest common factor, and finding the smallest number that divides a number, and then the LCM of two numbers by using a formula, and simplification problems we have seen, and finding the area and perimeter of the square field. And then finding the value when the power is in the form of a fraction, and expressing the following in the form of 2 power n, that is in the form of a square form, power form, that is 2 power n, 2 power cube, like that we have seen, and arranging the thirds, that is the number root numbers in order, that is ascending or descending order, and then we have multiplied that the root numbers and finding the addition of the decimal numbers, and we have found the integers of a and b to when it is positive integers. If it is in the form of a power b and b power a, we found that value of a and b, and especially arithmetic progression we have seen the nth term, that is 15th term, 24th term and nth term, and the common general term of T15 is Tn is a plus n minus 1 into d, and we have seen in the arithmetic progression itself we know how to find the number of terms in an arithmetic progression, and the sum of the n terms, that is 15th term or 16th term, any term, if they have given the arithmetic progression, we are able to find the sum of the first n terms by using this formula. And also by we are able to find, we will be able to find the value of that 17th particular term, 17th term or 16th term by using the general form. We can find the particular specific term, and then we have come across this geometric progression, general form of geometric progression, that is a or ar square, and goes on, and the sum of first n natural numbers, and the problem depending on this we have one sum, and the sum of squares of first n natural number, that is squares. First we have seen the sum of first n natural numbers, and next we have seen the sum of squares of first n natural numbers and the sum of cubes of first n natural numbers, and depending on that formula we have seen some few problems. And I have taught one technique here, how to find from the middle to the last term, and for square term I have taught, and then for a cube terms also, that is sum of the squares of cubes of the first n natural numbers. By using a formula we have found. And hello madam, hello, hello,
yes ma'am,
the session is over, ma. Just
okay ma'am.
I have the time is up, I think. I have the reference here. Can I show, or just I will give this as it is? That is
yes ma'am.
I have took all these problems in our website, Tamilnadu textbook, online textbook society only. I took if today wish means I will show tnschools.gov. In textbooks. If you go inside means TN Palli Kalvithurai, we will have that website. In that yes, it is opening. The materials what I have took today, I have got these materials from our textbooks, Tamilnadu textbooks. Here they have given from standard 1 to 12 marks. From standard 1 to 12. For example, I click standard 10, and then the medium is, they have given this many types of medium. I took this English medium, and they have given in terms also. The first term, second term. For 10th class, they have given the full book. So I click this full book and get my books. That is here. It is here our books. That is science books, social science books, and English books. Here math books and Tamil books. You click this math. Click here to download. That's all. We will have a video of that particular book. That's all. Like this, you go through. Like this, you please go through the books available in the website. For this week only, I told. And then I have also given the syllabus of this TET examination, for especially for mathematics. See here.
Yeah, thank you, ma'am.
Thank you, ma'am.
Yeah, participants, if you ask any questions, you give it to the chat box. Ma'am, show the reference again. Priyadashini asking, show the reference again.
It is nothing but I have given a link, no? In that link you have to go and I will show. I am going to give the PowerPoint to you, no? You can make use of that
Yes.
link.
Yeah, okay, ma'am. Sure, ma'am. And kindly share the Max TET PDF syllabus asking Priya B.
Ma, that also available in the PowerPoint. Ma, in the last slide I have given the references. In that references I have given the link of the textbook as well as the PDF form of the text syllabus with respect to mathematics.
Yeah. Prasita ma'am, can you ask something, ma'am?
No, ma'am. Actually, I have one request for the participants. Participants, you are posting the attendance and feedback form in the chat box and you are filling it. Kindly, please don't share the link with your friends who don't attend the webinar. So from today, the link will be active only for 20 minutes. Like we'll post the link before 10 minutes of the end of the program, and we'll immediately lock the attendance sheet. After 10 minutes, the webinar gets over. So kindly fill the feedback from attendance form immediately, and please don't share it to your friends. Thank you so much. Mutrani ma'am, you can continue, ma'am. Thank you.
Yeah, yes, ma'am. Okay, ma'am. Okay. Excuse me, ma'am. Ma'am, Jayanthi, ma'am. Meghalasi asking, you have been given a physical balance and 7 weights of some numbers in kilograms, keeping weights on one pan and object on the other. What is the maximum you can weigh less than 183 kgs? Easy way to solve this type of questions.
This is word problems. It is with respect to the division, ma. We have to give. I could not able to see the word problem here. For better understanding, if you post in the chat, I will see. It is a division problem. That's all.
Yeah. And thank you, ma'am. Priscilla, ma'am.
Thank you, ma'am.
Yeah. Priscilla, ma'am, you can start now, ma'am.
Oh, thank you, ma'am. Madhurani, ma'am. Ma'am, really, it's a wonderful session, ma'am. You have given a clear-cut and crystal clear information regarding this mathematics paper 2. Really, it was very informative. Behalf of the center and management, really express our gratitude to you, ma'am. It is very informative and very crystal clear information. I request Mrs. Divya ma'am, research scholar in TNTU and assistant professor in Mangalore College of Education to deliver her welcome thanks to honorable and most respected Dr. Jeyanthi ma'am.
Yes, ma'am. Thank you, ma'am. Good morning to Wandal Heather here. It's my... Hello.
Yes, ma'am.
Hi.
Please go ahead.
I express my gratitude to our Honorable Vice Chancellor, Dr. N. Panjanathan Sir, and respected Registrar, Controller, and all HODs of TNTU. First of all, I would like to propose hearty vote of thanks to our resource person, Dr.C.E.Jeyanthi, Deputy Controller, Assistant Professor, Department of Educational Planning and Administration, Tamilnadu Teacher TNTU, for making excellent presentation and making this webinar interesting and meaningful, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you.
I would like to extend a special thanks to my guide, Dr. N. Ramakrishnan, sir, Member Syndicate, Professor and Head, Department of Educational Technology, TNTU, for providing encouragement and support. Thank you, sir. I express sincere, hearty vote of thanks to our college secretary, Dr. Ashok Kumar, sir, and our respected Managing Director, A. Sakti Praneshwar, Mangekasi Group of Institution, for their great support. Thank you, sir. And I would like to thank Dr. M. Arokya Priscilla, Principal, Mangekasi College of Education, for their support. Thank you, ma'am. I extend my sincere thanks our technical team members for making this event successful with your contribution. Once again, thank you all. Thank you, ma'am.
Thank you, ma'am.
Yeah, thank you so much, ma'am. Shall we wind up the program, ma'am?
Yes, ma'am.
Thank you.